Hi friends, welcome to chemistry online classes. In the last class, I discussed about the aldol condensation reaction. So, what are the conditions required for this aldol condensation reaction? One is alpha hydrogen contain aldehydes or ketone, any one, not both. Okay. And second condition is dilute base. Anyone you can take NaOH, KOH or like this sodium alkoxide, that may be methoxide here. If you put R, that is methyl group, then it is methoxide. If you put ethyl, then ethoxide, that is. Now, if you take this is a functional group. Aldehyde, we have G meaning what is it? Functional group. This functional group, next carbon is known as alpha carbon, next carbon is known as beta, next carbon is known as gamma. So, next carbon alpha. So, we record which one? Alpha hydrogen. And alpha carbon hydrogen, that is called alpha hydrogen. Generally, it is taken 2 moles. Then, this is an aldol. This is aldehyde group. This is an alcohol group. Then, total it is known as aldehyde group ALD, and functional group of OH is known as OL, aldol. Okay, this is functional group. Next carbon alpha, next carbon beta. So at beta position we have the hydroxy, that's what is known as beta hydroxy aldehyde. This is not a IUPAC name, just is both functional group respect to a name given is beta hydroxy aldehyde. If you want the IUPAC name, is the first equation 1, this is 2, this is 3, this is 4. 3 hydroxy, total 4 carbon, butane, E ring, add Al functional group name. So 3 hydroxy butanol. This is after heating. If heat symbol not there, that time they may give the any dehydrating agent like concentrated H2SO4 like this, they will give. Generally many of the cases heat symbol is there. On heating, this is lost as a water molecule. This is H and this OH. Okay, so H and OH lost water molecule H2O. Then we got here alpha beta unsaturated aldehyde. This is a functional group. Next carbon is alpha, next carbon is beta. So at which position unsaturation is present? At alpha and beta position unsaturation. Unsaturation may be double bond, triple bond. So this is called alpha beta unsaturated compound. It aldehyde may be or ketone. Now here aldehyde is there. If you take ketone, that it is ketone. Okay, alpha beta unsaturated. Now aldehyde is, that's why we will write aldehyde. Okay. Now compared with this aldol, this one somewhat stable. Reason, it has conjugation, double bond, single bond, double bond. So unsaturation, it is what you call conjugation is present. Conjugation means what is that? Alternate double bonds. Double bond, single bond, double bond. So comparatively this aldol is somewhat stable. But keep in mind, here aldehyde also participating, ketone also participating. When aldehyde participates, aldol also somewhat major product. On heating it gives this one. If you don't heat up to here, it is major only. But ketone aldol product formation, that is generally called ketol. But ketol word nowadays is not used. That is also pronounced in some cases aldol only. Here aldehyde is there and OL is there, what you call aldol. If ketone group is there, ketone plus this whole ketol word is used. But nowadays that word also not used. That is also sometimes it is pronounced as aldol only. So when ketone is used here, this formation is very less. It means ketone formation is very less, because already we discussed in the reactivity, ketone is more stable than the aldehyde, that's why its reactivity is less. Therefore, in many books, if you observe, with respect to aldehyde only aldol reaction is there, but with ketone very rare reaction. That also not in this respective base, any other base or in acidic medium it will participate, not in basic medium. Because in acidic medium reactions are somewhat fast compared with the basic medium for this aldehydes and ketone. That also we discussed in the first one. Now, this name already I discussed in the nomenclature. What is the name of this compound? You can give the number numbering from here 1, 2, 3, 4. Total how many carbons are there? 4. Then we can say here but second position double bond is 2 E. Actually E means E and E. But remove this E here. Actually E is there. But remove. So I am removing this is and aldehyde is there. Then this is called enol. But 2-enol. It's IUPAC. But common and very important. IUPAC anyone can write this easy because rules know you can easily write. But common name of this one is known as crotonoldehyde. Crotonoldehyde. You have to remember this. There is no any rules for remembering this common name. You have to remember this. Okay. Now carefully observe. If you want the mechanism, because always directly upon write this product, there's a little bit mechanism I will give here for this reaction. CH3, C double bond H. How many moles we took here? 2 moles. So one of the mole. This is I want to separately CH2 and H. This is called CH3. CH2 and H totally is CH3. So now we have the base OH minus. Anyway, if you take how it is dissociate. Na plus OH minus. This base part OH minus will base mean what is the proton abstract. Base mean what is the proton abstract. It takes the proton. So it takes proton. Now it is H plus because already I told you that where it goes there is negative part, from where it comes there is positive part. It is moving from the hydrogen that it is positive. It is moving towards the carbon that it is negative. Now we will get this is generally fast reaction. When fast is there, generally equilibrium symbol will be there. Now CH2 minus C double bond OH. This OH and H, it gives which one? H2. Now this will undergo resonance. This will become here. This will become here. Then we will get here CH2 double bond CO minus and H. This is called E and total is pronounced as enolate. Last class somewhere I given like this CH3C double bond O minus carboxylate. Then here this is enolate. So this is intermediate in this reaction. Keep in mind enolate. So right now I am going to say intermediate. This is actually intermediate. In many competitive exams, this question is asked in aldol reaction, which is the intermediate, enolate. If this reaction is carried out in acidic medium, that it is known as enol, because that H will be there here. E plus OH, OH means all, then enol. Generally, many of the books given in basic medium only, this reaction also carried out in acidic medium. If you don't know, because our textbook also given it in basic medium only, but actually it is carried out in acidic medium also. That time intermediate is enol. Here enolate is there. Okay. Now this 1 mole. When you take the 1 mole aldehyde, second mole of aldehyde is there. So here I will take the second mole of aldehyde. CH3 C double bond OH. Second mole of aldehyde. This negative part will comes to here, and this will be actually comes to here. Like this. Then it is negative part. This negative part will attack to this one. But like this is generally not represented in books. Actually how it is represented, like this only is represented. You have to understand, this is goes to here, this negative attached to here. But that type of representation is not good. That's why directly this pi bond attack to which one? This carbon. Immediately this pi bond shifted to oxygen. Then now this is RDX step. RDX means what is it? Not bomb here. RDX step is. Here this is RDX, rate determining step. Okay? This is called limiting step also. This is. But you will learn in the chemical kinetics. Now it is not completed, so you don't know. That's why I will not discuss much about this. This is called rate determining step. It means how fast this reaction occurred decided with this step only. Now, carefully observe this CH3, CO minus and H. CH3, CH, CH. This is O minus, O minus. Next, what is it for this carbon atom? CH. CH2. Along with this, what is it? C double bond OH. This is double bond. This negative comes here, double bond, and H is everything is there. And here already one water molecule is there. So this water molecule here, this will be like this. Then you will get here CH3, COH, H, CH2, C double bond OH. Along with this, what is that? OH minus. This one product is this one. All and all. CH3, CH, CHOH, OH, CH2, CH2, C double bond OH. This all and all. Now on heating, this is called condensation product. Condensation means what is that? Removal of smaller molecule. This also will come in polymer chapter. I think according to this corona time, this polymer chapter may be totally removed. That's why it may be not discussed much. But keep in mind, condensation means what is that? Smaller molecule like water, ammonia, HCl, like this molecule removal. So here water molecule removal. I shown here H and OH lost. Then we will get here CH3, CH double bond, CH and C double bond OH. This is protonoglycate form. This is the mechanism. Then if you learn this mechanism, what is the use? Nothing is there. What is the intended you learn here? Because in competitive exam for CET NEET level, this question will ask that purpose I given here. Next, I given here RDS, rate determining stress. Based on this, they will ask the order of the reaction. Now I am not discussing reason, you don't know what is the order like this, because in chemical kinetics chapter, you will know this. After knowing that, you just try here what is the order of reaction. If I discuss again, it is taking some half an hour, so I am not discussing it. So these questions will ask in the NEET and JEE Mains and CET level. So this step is very, very important for competitive exam. Otherwise, please see of this. But keep in mind, conditions are this one. And then ask a question sometime, which of the reaction is having the carbon-carbon bond formation? See, these are individual, 2 moles are here. In between this is one group, this is one group. CH4, CH3 actually, this is one H, one here. Then 2 bonds are in between carbon-carbon, what is going on here? Covalent bond. So this is one of the reactions which form the carbon-carbon bond. Sometimes they may give us a question, which of the following form the carbon-carbon bond? Dimer-dimer reaction already in alcohol completed. This one reaction or any other reaction. In dimer-dimer also carbon-carbon bond form. In this order also carbon-carbon bond formation is there. So this is not this chapter question. It is combined question because in alcohol also they may ask the question and haloalkane all chapter combined one question they may ask. So immediately you will not guess the question which is carbon-carbon bond form. That's why I am giving it. Here it form the carbon-carbon bond formation takes place. Now, I took here one example. Second example. Second example is CH3, CH2, C double bond OH. Its name is acetaldehyde. This is acetaldehyde. Its name what you call propionoldehyde. Common name I am writing here. Otherwise, IUPAC name propanol AL. Propanol IUPAC name. Now, if you take the 2 moles in, like this also may be given 10% OH minus. Now I wrote here dilute NaOH or dilute NaOH 10%. They will not add any, they will add only OH minus. That also you have to consider as a base. Okay. Then what will be the product? Here I explain this with respect to this in the last class. CH3, C double bond OH and CH2H, C double bond OH. How many moles these are? 2 moles. One hydrogen added with this, then it's converted to this one CH3, CHOH, and remaining CH2 is in CH2, CH2, C double bond OH. Without mechanism. Actually, right, if you write the mechanism, this is happening. But always we can't write the mechanism That's what you have to do. Put together and write the product. Same thing I am doing here. Carefully. First molecule I am writing here CH3 CH2 CHO. CHO. Now one more molecule I am taking here. Carefully observe. CH3. It means I will write this H2 here and I will write H here. One H gone, one of the hydrogen. And this will be CH2 C double bond OH. Then what is the in between this bond? But this is not the product. Why I will always explain the wrong first thing, what the student will do, that first I am writing here. Because our concept is compulsory what is required here? Alpha hydrogen. But this is which type of hydrogen we will here? This is a functional group. This is alpha. This is beta. That's why this is not the product. Now expect what is the product? CH3, CH2, CH. Other will get down also no problem. And this O. And here CH, C double bond OH. This I will get down. CH. Total how many moles is 2 moles. Actually here what is the CH2? One H gone to here. Now bond between this. If you write the mechanism, it may take 1 or 2 minutes. So just combine the 2 molecules. Okay. Now we got this is the product. This is the correct one because this is functional. This is alpha. And keep in mind, in aldehyde condensation compulsory beta hydroxy aldehyde or ketone form. If you observe this is alpha functional group alpha beta, this is gamma. Which hydroxy form here? Gamma hydroxy. That is not correct. So how to identify immediately in examination? Aldehyde reaction in beta hydroxy aldehyde ketone will form, not gamma, not delta. Simple. This is one of the traits. Now observe here. Functional next carbon alpha, next carbon beta. That's it. This is the correct. Clear this is? Yeah. Along with this, if you heat it, then what will you get? Here one hydrogen is here OH. Water molecule is CH3, CH2. Here C this H, CH. This bond and this bond will come here. Double bond. This H and this H. Totally no H here because carbon value should be satisfied. And C double bond OH. Clear this concept? Now, along with this water molecule eliminate. This is condensation. This is required or not, it depends on the reaction. If heat symbol is given, then it form. Otherwise, no. That's the student don't know in examination. Aldehyde condensation they will write up to here. Aldehyde condensation up to here like that. Aldehyde reaction up to here only because aldehyde and alcohol. Because in examination we will not read the complete sentence. That stress will be there in examination. Then this option also may be given, this option also may be given. Then that is confusion. That's why read the question clearly. Which is given? Aldehyde only given or aldehyde condensation is given. That is very important. So now we got the clarity. Compulsory, which is required, alpha hydrogen only participate, not beta, not gamma. What is the product form? Beta hydroxy product form, not gamma, not alpha. So that is, if you know clearly, then you will easily get the product. Now, if any butanol may be given, this is a question I am giving homework for you. 2 moles CH3, CH2, CH2, 1, 2, 3. This is 4. 2 moles I took here. Now I have nothing given here. Just OH minus also given. We have to consider that is aldehyde condensation. Now write both aldehyde also and condensation product also write. Clear this? Now we will go with the ketone. Now aldehyde is completed. Ketone we will do now. Now I am taking the ketone. That is CH3, C double bond O, CH3. This reaction taking place in presence of dilute barium hydroxide. Otherwise, this will undergo in acidic medium. Keep in mind, these are very important. Here I explain with the NaOH, but here not. That is also one of the important. Generally, this ketone will undergo in presence of barium hydroxide, otherwise acids, that is or HCl. Keep in mind, because somebody lectures will know only in basic medium. It's not only in basic medium, it also undergoing acidic medium. Generally, ketone will undergo in acidic medium because its reactivity increases in acidic medium. Very, very important condition. Now, carefully, here also how many moles we have to take? 2 moles. Now, here I will not write always mechanism. Always mechanism, that is not the correct. How to write? Just learn. Just 2 moles. CH3, CH3, O. How it represented here also same. This is 1 mole. Another mole I am writing here. First you should know what is alpha, what is beta. This is a functional group. This is also alpha, this is also alpha. Now 2 sides are there. Aldehyde in one side is there. So functional group, next carbon alpha, next carbon alpha. Don't get the one side alpha, next beta. This is not the correct. Okay, this is we know very well. CH2, C double bond O, CH3. This is another mole. But I written here CH2 only. That H I will add here, one more H. Clear? Then what is it now? Bond. Now check. It is which type of hydroxide? Alpha hydroxide or beta hydroxide or gamma hydroxide? Then only we will know that it is what we wrote that product is correct or not. So now this is a functional group. Here also functional group is there. But which is first priority according to nomenclature? Aldehyde ketones are first priority than the hydroxide. So this is a functional. Next carbon what is that? Alpha. Next carbon what is that? Beta. So what we wrote the product is that is correct. So beta hydroxide aldehyde ketone only will form. Well done. Next, if you take, now I will write in place of barium hydroxide only consider. Now I will write separately HCl. 2 moles of CH3, C double bond O, CH3. Now I am taking HCl separately. It may take either barium hydroxide or HCl. Then automatically same product form, same CH3, COH, CH3, CH2, C double bond O, CH3. On heating, what will take place here? Condensation. Water molecule eliminate. Here one H, here one OH. I will write minus H2. Minus is eliminated. Okay. So what is the left that we will write? CH3, CH3. Now this will out. Here one hydrogen. Then here one double bond. Next CH, C double bond O, CH3. Here is it. Its name, mesitile oxide. This is given in the nomenclature. Already given this is nomenclature. Common name is not IUPAC name. Here common name important. That's why I am writing this. IUPAC name already given in the IUPAC nomenclature separate. That time you can check it. So now if one mole again, if HCl and CH3 this is also what is it? HCl CH3 C double bond to CH3. For your convenience purpose I am writing like this. Otherwise normally you can write like this also, no problem. Same thing. Condensation product. See, if you form ketone, ketone plus all, it is ketone. This is. Now we can pronounce this ketone also. This is condensation product. To form ketone, actually here how many hydrogens are there? 3. So how many hydrogens are here? 2. 1 hydrogen, 1 here. For condensation, how many hydrogens are there now here? 1 only. It means 2 hydrogens are lost. Up to condensation, 2 hydrogens lost, and up to ketone or 1 hydrogen is lost. Okay. Therefore, to form the condensation product, minimum how many hydrogens are required? 2 hydrogens required. 2 alpha hydrogens are required. To form alpha or ketone, how many alpha hydrogens are required? Minimum 1 required. That you have to learn. So now, I am writing the condensation product. K3 also. I am writing the condensation product. First ketone form, next condensation. So how many hydrogens are there here? 3. Minimum 2 required, 1 extra, no problem. So now this 2 hydrogen I will write separate. This is H, this is CH. Total what is that? CH. Water molecule last. Then what is the product form? As it is right, CH3, CH3, double bond, CH, C double bond O, CH, CH. Now double bond is a double bond, CH3, CH. This is called 4O, not 4O. Okay. These are there in our syllabus up to, but not written in textbook. Heading, what is that? Aldol reaction. What are the requirements? Alpha hydrogen containing aldehydes or ketone. Then ketone is respectively there. Don't say this is not present in the textbook. Ketone, what is there? This reaction also they may ask. 3 mole taken in 4-on form, 2 mole taken in up to methyl oxide form. That you have to keep in mind. So you told up to 4-on, but in some books you up to methyl oxide. That depends on how many moles they took. 2 moles taken in methyl oxide form up to condensation. 3 mole taken in condensation product 4-on. That is in acetic ingredient. If barium hydroxide is there, up to this methyl oxide form. Condensation product is not wrote here. Methyl oxide form. Next will rare in the participation because this is basic medium. In basic medium, this aldol reaction rate is somewhat less compared with the testing medium. Clear this? Now the question is, sometimes they may give the products and we have to write the reactant. Reactant given product writing now easy because I explain now. They will give the product, write the reactant. What is the reactant? That also we have to discuss. Now question for you, one more. This question very important. Option A. In this reaction or there, whatever is any aldol condensation between on heating, water molecule eliminated. Already you studied in the first year also or in second year. Elimination reaction E1, E2 like this. So here elimination is there. Water molecule eliminated. Which mechanism this is? Option A, E1 mechanism. Option B, E2 mechanism. Option C, both may be either E1 or E2. That's why we will write may either, what do you call both we can write better. Neither is there. E1 and E2. It depends upon the condition also, right? Like this. D, none. Then what is your answer? I am not explaining here. Already you learned in previous section. That's why based on that knowledge you decide. Question is what is that? In condensation of aldol reaction, what is the mechanism? E1 or E2 or both or none? You decide. If you don't know, later you can ask. Okay. Now the question is what I told here. Product given. Then we have to write the reactant. I will write the one reactant. Then that reaction level. Now already you learn this one. That's why I will write this product only. What is the product? CH3, CH2, CH, double bond, CH3, C double bond OH. Aldol condensation reaction, what is the multiple bond, that is double bond present in between alpha and beta. Now check aldehyde. Next carbon is what is that? Alpha. Next carbon is beta. So double bond present in between the alpha and beta. Just break this bond. Break this bond. At beta carbon add a double bond O. Always beta carbon should get a double bond O. And alpha carbon should get the H. Check now. Because this is the product. Now I am writing the reactant. CH3, CH2, C. H already is there. Now double bond OH. Only here it is. Next, this one from down. CH3, CH, CH3. It depends upon how many carbon valency you have to satisfy. I wrote here one H only, but you have to satisfy the hydrogen carbon valence. If I write only H and like this.